We're going to do long division and a thing called synthetic division. If you were here on Friday, we took the quiz, and then after the quiz, we watched a little intro video into doing that. So I'm going to do more of a formal lesson here. I'm going to do a few examples of long division and then a few examples of synthetic division and show you there. So I wanted to review long division because you probably haven't done that since you was in elementary school, maybe third or fourth grade, since you've actually written out long division and followed the steps. The reason being is polynomial long division is the same rules as regular long division. Okay, so we look at that. We're dividing 4 as the divisor. 1047 is your dividend. That's your dividing into that. So we want to look at and say, okay, what times 4 will get me the closest to 1? Well, nothing. I can't. 1's too small. So I go to the next number. What times 4 will get me closest to 10? 2. So I'll put a 2 up there and then multiply. And then what do I do with these two numbers? Subtract. So I'm subtracting 8 and get 2, and I break down the 4. What times 4 gets me closest to 24? Happen to be 6, and that is 24. Subtract. That's 0. Bring down the 7. What times 4 gets me closest to 7? 1. 1 times 4 is 4. Subtract. 7 minus 4 is 3. Does 4 go into 3 any? No, it's too small. Once this gets smaller than your divisor, you know you're finished. This is called the what? Remainder, okay? And in elementary school, we usually wrote it like that. I remember putting the R and the 3 there. Been a while since you did that. Now, with polynomials, we don't write it that way. We don't do R3. We do look for the remainder. That's one of the key things to doing the higher degree polynomials is looking at that remainder. But we're going to write them today kind of more in a mixed number format. That this is the same thing, right? That 4 into 1047 goes 261 times with 3 out of 4 left. In math, I don't think we explain this well in younger grades, that a mixed number is really shorthand for that, for an addition problem. That's what a mixed number is. It's shorthand for an addition problem. So what we're going to do with polynomials is we're going to write the remainder over the divisor added to the quotient. Okay, the quotient is 261. That's the answer. The remainder is 3. But when we're doing a polynomial, this is the way we're going to write our answers. We're going to have a quotient plus the remainder over the divisor. That's going to be our process every time for that. So long division, we're looking at that. That same process works with polynomials. When you take two polynomials, and this will be our first real polynomial example, we're going to take 3x squared plus 22x plus 30. We'll start out with an easy one and divide it by x plus 6. Okay, so a quadratic divided by a linear, which is fairly easy. Now, what we'll discover here as we go along is that when your divisor is linear, i.e. it doesn't have an exponent on the x, then you can use synthetic division. So, but I'm going to introduce long division with this because it's easier. Okay, and once you see the process, we'll get to ones that are more difficult out of that. So we're going to do this division. So we set up the long division. We put our divisor on the outside, x plus 6, and our dividend on the inside, 3x squared plus 22x plus 30. Key things to remember as you're setting this up. Descending order. That should be second nature for you with polynomials now. We've been doing that, the operations and things like that. We always put our answers in that descending order. Want to make sure your divisor and your dividend, both of them are in descending order. Okay, if they're not, then put them in that order. Makes the division much, much easier to do. And then also you want a representative for each power. So what that means is, like, if your dividend or your divisor has an x squared in it, and that's the biggest piece, You want to have x squared, a plain x, and a number. If it starts with x cubed, then you need to have an x cubed, an x squared, a plain x, and a number. Okay. If one of those pieces is not there, put a 0 in its place, a 0x squared or a 0 something in its place. We'll see some examples of that in just a second. Okay. Listen, could you please? I don't know if we got anything plain or not. That really matters. All right, now, so descending order representative for every power, and we'll see that more as we go along here. I have some that have some missing powers. Okay, so first steps are looking at the front of your divisor. Don't look at the entire divisor. Just look at the leading term, the front term. It's in descending order. So we're looking at x. The plus 6 is just going to kind of be, it's going to make some things happen, but it's not the biggest part of this. We're going to look at x. And we look at x and say, what times x would get me 3x squared? 3x. And I'm going to put that above the x's in that. So the way I look at this is I think about it in terms of columns. That you've got an x squared column, you got a plain x column, and you got a plain numbers column. That keeping it organized like that will keep you from getting confused. Okay, so now the next step when we did long division with the number is we multiplied what we put up here times the divisor. So we're going to do the same thing here, but that's going to be what property? Distributive. We're taking 3x times x plus 6. So we have to say 3x times x. That's our 3x squared. That's the one we wanted. That's the one we were working toward. And then 3x times 6 would be 18x. Put that part in parentheses. And then again, long division, the next step was to subtract that. So we're subtracting 3x squared plus 18 from this stuff. Okay? What happens to the 3x squareds? Cancel out. That's what we were trying to do. That worked out great. Then we're saying 22x minus 18x. 4x. So we bring the 4x down. And then we bring down the plus 30. Okay. And then we do the same thing again. What times this x in the front would get me this 4x here? 4. Positive 4, so it would be a plus 4. Again, that's going to go over the plain number column. Then we distribute positive 4 times x plus 6. That's going to be 4x plus 24, parentheses, subtract. 4x minus 4x cancels out. 30 minus 24, 6. Now, how do I know that 6 is the remainder? Yeah, there's not another number I can bring down. Also, I got an x there. There's nothing I can multiply x by and get rid of it, right? And get 6, right? So that's also, there's not another number to bring down, and I can't multiply something times x and get that, okay? So that's my remainder. The way I'm going to write my answer is I'm going to write 3x plus 4 plus 6 over the divisor, x plus 6. Okay. 3x plus 4 is the quotient. 6 is the remainder. So if they ask you for different parts there, quotient, we get when we divide, the remainder is what's left over. Okay. So long division, it's long. That's the name. Okay. Let's look at one that's a little longer. That is more of the why we need long division, because you can't do synthetic division on every problem. That just doesn't work. 3x cubed minus 6x plus 13, that's our dividend, divided by 3x squared minus 3x minus 6. All right. So set it up in a long division situation. I would have to do long division on this one because my divisor has a power of 2. I don't have the option. When you get your practice today, they're just mixed together. Some of them you're going to have the option to do synthetic when we talk about that, and you will. I want you to do synthetic when you can, but this one is a have to do long division because the divisor has an exponent bigger than 1. That's how you know you got to do that. So setting that up, we got 3x squared minus 3x minus 6. There was a representative from every power, x squared, plain x, plain number. It's in descending order, so that I know I'm setting up right. On the inside, is that in descending order? Yeah. There's no x squared, so what do I have to put in its place? 0x squared. So I put a plus 0x squared minus 6x plus 13. Again, you want a representative from every power going down. Not that technically you can do it without it, but it's going to get confusing because you'll have some pieces that don't match up with other pieces out of that. So if you have a representative, then you know, oh yeah, I got an x cubed column, I got an x squared column, plain x, plain number column. So those columns, it really helps you keep organized better. Okay. Now, next step, what times the front piece gets me the front piece? Just x, right? So I'm going to go over to the plain x column and put x. And then what do I do with that x? Multiply it back to the divisor. So x times 3x squared, 3x cubed that I was searching for. X times negative 3x, negative 3x squared. And there's the reason I need the x squared column, because there's an x squared in that first piece that I'm subtracting. And x times negative 6 would be negative 6x. And I'm parentheses and subtract. Those parentheses and the subtraction is important. Most people that don't put those parentheses end up making sign mistakes. Even some people that do put the parentheses make sign mistakes. All right, so what happens to the x cubes? They cancel each other out. That's beautiful. And then 0x squared minus negative 3x squared. Positive 3x squared. Negative 6x minus negative 6x. 0x, so I'm just going to put a plus 0x. And then I'm going to bring down the 13. Because there was something left. As Austin said earlier, there was something left to bring down. Okay. What times 3x squared gets me 3x squared? 1. So I'm going to put a plus 1 up here. Because it's positive 1 that gets us a 3x squared. Distribute. That's an easy distribution. Don't have to even think. Copy it down. And subtract. X squareds go away. 0 minus negative 3 would be positive 3x. 13 minus negative 6. 13 minus negative 6. Positive 19. Now, as Austin said earlier, there's nothing left to bring down. So we know, hey, that should be our remainder. We also know 3x is smaller than 3x squared, right? The degree is smaller. The exponent is smaller. So that's how we know we're done. So that means our remainder is 3x plus 19. Okay. Quotient, x plus 1, plus the remainder, 3x plus 19, over the divisor, 3x squared minus 3x minus 6. That right there is the final answer for that. Learning this process of long division. You're not going to do a ton of long division the rest of this chapter, but it goes right along with synthetic division. We'll do long division. When we get into rational functions, we'll do more long division in that. But the skill set, learning it now is fairly important. Let's look at, do one more long division, just to make sure we got it knocked out. I think you guys got a good handle on it. So let's take 7x to the 4th minus 8x cubed plus 16x squared plus 30 divided by x squared minus 2x plus 3. Excuse me. Set up your long division. Descending order. Make sure everybody's there. 7x to the 4th. Negative 8x cubed. 16x squared. What else do I need to put in there? 0x, because there's not a plain x in that dividend. All right. What's our next step? What times x squared gets me what? 7x to the 4th. So that'd be, yeah, 7x to the 2nd. And I'm just going to put that over that. Keeps me organized. Distribute. Minus 14x cubed plus 21x squared. Parentheses, subtract. X to the 4th cancel out. Negative 8 minus negative 14. Positive 6x cubed. 16 minus 21. Negative 5x squared. And then I'm bringing down the 0x. If you want to go ahead and bring down the plus 30, you can. I always just wait till I need it to bring it down. I don't need it here because I know my divisor has 3 terms, so I need 3 terms in what I'm dividing into. So, what times x squared gets me 6x cubed? 6x plus 6x. Nice. Cubes go away. 7x squared. Negative 18x. And then now I'm going to bring down the plus 30. What's that last piece there?
Plus 7 at the top.
Plus just a plain 7 at the top. Good job. Distribute across there. And subtract so we can get that remainder. Negative 18 minus negative 14. Negative 4x plus 9. Good job. So my remainder is negative 4x plus 9. My quotient, 7x squared plus 6x plus 7 plus negative 4x plus 9 over the divisor, x squared minus 2x plus 3. Long division, fun thing, right? Long division, that's long. A lot of operations involved in that. You look at all the operations that were involved in that problem. You had, if you count finding the parts you've got to put up top for the quotient, that's 1. And then there's 3 multiplications, 3 subtractions, and then another find what's up top, another 3 multiplications, we're up to 11, and then 3 subtractions, that's 14, and then another one up top, that's 15, 3 more multiplications, that's 18, 3 more subtractions, that is 21, and then the remainder is what's left, and the final answer, so that's 22 steps or things that we did to get that problem done. So A lot of things happening there. So a lot of places you got to be real detail oriented with this particular stuff because 22 things to do in that problem. If you missed one of them at the second step, well, it messes up everything you do after that. So you've got to be really careful about that. Be very, very careful about that. All right, let's look at synthetic division. Synthetic division takes the idea of long division and it works for linear divisors. Okay, so synthetic division only for linear divisors. By linear divisors, I mean something that looks like mx plus b. So linear equations, y equals mx plus b. So something that looks like that is what we're looking for there. All right, so let's look at doing a synthetic division problem. Start with 2x cubed minus 19x plus 8 divided by the linear divisor x minus 3. Okay, now setup is similar to long division in that you need to have a representative from every power, and it needs to be in descending order for your dividend. Okay, the divisor, we're going to do synthetic division. What we do is we set up a bracket or like a box here. Okay, so draw yourself like it's laying down L, and then put a little shelf on there. Okay. So the setup is you take your dividend, what you're dividing into, and it goes on the top line of this. So 2 for the x cubes, 0 for x squareds, negative 19 for x's, and 8 for the plain number. Okay, so that's just the coefficients. Notice I didn't put any letters in there. Okay, synthetic division takes the letters out of the problem, so you don't have to deal with them. Okay. Now, on this little shelf out here, you've got to find what number goes there, and that comes from the divisor. What you do is you set your divisor, x minus 3, set it equal to 0. So set the divisor equal to 0 and solve it. Get x by itself. That's going to be x equals 3. That 3 goes on the shelf. That's where that's coming from. Okay. So take your divisor, set it equal to 0, solve it. That'll get you the number that goes on the shelf. The next steps are the workings of synthetic division, okay? The first step every time in synthetic division is drop the first number down to the bottom. Drop a 2. And then multiply. 2 times 3, 6. Then add. 0 plus 6 is 6. Multiply. 6 times 3, 18. Then add. Negative 19 plus 18 is negative 1. Multiply. Negative 1 times 3, negative 3. Add. 8 plus negative 3 is 5. This number is your remainder. These are the coefficients of your quotient. Okay? Anytime you do synthetic division, you're taking the original polynomial, the dividend, and you're bringing it down by 1 power of x. If it started as x cubed, bring it down 1 power, it would be x squared. So the 2 is the coefficient for x squared. So this is 2x squared plus 6x minus 1. That's the quotient. The remainder is 5, so we put plus 5 over x minus 3. Much shorter process than long division and much less room for error because you don't have to deal with the double minus signs and all that stuff that's going on with the subtraction in long division. The synthetic division kind of simplifies things a lot, but it only works with linear divisors. Okay, it breaks the power down by 1. Let's look at another one. 3x squared plus 22x plus 30 divided by x plus 6. Do Descending order. Make sure everybody's got a representative. 3, 22, 30. What goes on the shelf for this one? -6. It's going to swap that sign every time. That's all it's going to do to it. Now, what's the first step? Drop the 3. What next? That's right. Multiply. 3 times -6. -18. Add. 22 plus -18. 4. There you go. 4 times -6 is -24. So, and then add. 30 plus -24 would be +6. That right there is your remainder. Okay. Not that you have to write that every time. I'm just trying to point that out. That last number that's there is going to be your remainder. Quotient, 3x plus 4, because we took a squared and brought it down 1. So that's where the 3x comes from. 3x plus 4 plus 6 over x plus 6. If you remember, that was example A. Same problem. A lot less work, right? So that's what the beauty of synthetic division is. When you're dividing by a linear divisor, it's much easier and quicker to do, okay? And a lot less dealing with letters and double signs and all that stuff. So synthetic division is just great for that. Let's take this one. 18x squared minus 18x minus 10 divided by 6x minus 3. Okay. Set up your synthetic. 18, -18, -10. And then what goes on the shelf for this one? Which is, so when you set 6x minus 3 equal to 0, 6x equals 3 divided by 6. That reduces to be 1/2. So we got a fraction on the shelf, which is okay. It's not the end of the world. It's just a more difficult number to deal with, but it's just still a number. So follow the same rules, though. Drop the 18 down. Multiply. It's half 18. 9. Add. -9. Multiply. Let's leave it as an improper fraction. That'd be -9 over 2. And again, we're going to add. And to get that remainder. So -10 plus -9 over 2 would be -29 over 2. Right? -10 is 20 over 2. So there's our remainder. So we get 18x minus 9 plus -29 over 2 over the divisor, 6x minus 3. What we will see later Wednesday is when that remainder is 0. That's a special circumstance with polynomials, and it allows us to find out that that is a factor of that polynomial. So synthetic division is going to be handy for taking bigger polynomials and breaking them down into smaller pieces out of that, which makes it much easier to solve when you get there. So a little bit of practice on paper today and tomorrow. Got a lot of time left in the class today. there are 15 problems on here. They're mixed up. Some of them you can do with long division only. Some you can do with synthetic or long. I suggest any of them that can be done with synthetic, do with synthetic. That because you're going to be using that more in the coming weeks. So make sure you can do synthetic division today. So go ahead and start on this, and then that way you're not bombarded tomorrow. And we'll see if I can find a little bit of complicated. It's not much. I'm got that. Stick some stuff together. Work out right. One extra, two extra. And there will be some. Everybody got one? All right. So you look at that, number 1, number 2 can be synthetic. 3 and 4, 5 and 6, got to be long division. 7, 8, and 9, synthetic. 10, long. 13's got to be long, and 15's got to be long. Good mix there. Can I say that again?
Sorry.
Ones that have to be done with long division have an x squared in their divisor. So number 3, 4, 5, 6, 10, 13, and 15. The rest of them I would do with synthetic. I don't want you to do synthetic.